decrease? Doesn't have one. And exponential growth is only what? Increasing. So what is the domain interval for which is increasing? So the lowest x value that it starts increasing at is 0?
It's gonna be none, because it don't have a...
Remember, we're on increase. You're looking at that growth that's not increasing at all?
Yeah, it's increasing, they don't have any...
Notice, like, if I put a tangent line in there, we talked about it before, see how it's a positive slope? It's increasing. Come on, what's the lowest x value? Remember, it's domain intervals. It's the lowest x value it starts increasing at. Negative infinity. Right? It's increasing all the way through here. It's really small, but it's starting there. And so, Grace, you said 0, right? But again, you're thinking about the y. It's domain intervals. What's the maximum x value it's increasing over?
It's weird, because 0's on the x and y axis, like, the same number, if that makes sense. Like, this one has a -1 and 1 and -1, but they share a 0. Like, there's not
Well, they
four
share
zeros.
0's common 0, but that's not a point on that graph.
Yeah.
So what about my interval, the decay? It's only going to decrease. What's the domain interval over which it decreases?
Negative, I mean positive.
Well, yeah, it's decreasing.
Positive infinity to what?
Would it be like the thing you said earlier where we put the minimum and maximum?
Oh, that's not right.
If it's interval notation, it's always a minimum to a maximum. Also remember, it's a domain interval. What is the lowest x value where it starts decreasing? Negative infinity. Remember, left versus right. Domain interval is in this direction. So it's up here, it's decreasing, decreasing, decreasing. So it starts decreasing at negative infinity, stops decreasing at positive infinity. Actually, technically it doesn't stop because it goes to infinity. Okay, questions? So, we are learning about a new number today. It's an important one. Unfortunately, I hate lecture, but we're going to have to do this so that we can get through some of these things and still be able to learn everything we need to learn. Does anyone need me to leave increase, decrease up on the board? We good? So, Helen is opening her first savings account. By the way, this is M3-111, I believe. Okay? We have one back there. Have you written in yours yet?
Nope.
Grab one of those, write in it, bring your textbook and put yours back there. So, suppose she decides on a bank that offers 6% annual interest to be calculated at the end of each year. So write a function a of t to model the amount of money in Helen's savings account after t years and determine the amount in the account at the end of 1 year and 5 years. Is it a safe assumption that we do not know the compound interest formula from Algebra 1? Safe assumption?
Never even heard that word.
Yep. Huh? What is compound interest? So, the formula is actually given to you right here. So, a of t is equal to p times 1 plus r divided by k raised to the kt. Okay? And so let's break down what this means. This is also there. P represents the initial amount. What is the initial amount that Helen deposits? $500. It's still a 1. What is R? Interest rate. So what? It's 6. There we go. Remember, that's 6%. So as a decimal, that would be, okay, 6% is equivalent to 0.06. And so we need that 0.06. What is K? Okay. And do they tell us anything about how often they're going to compound that interest? Nope, so we're gonna assume that it's compounding once a year. And then, so K would be 1 times T, which would be,
Time of year.
time in years, so what am I gonna put there? Sure. Is it always 5? Notice how it asks for 1 year and 5 years, so T is actually my what? Variable. Notice how it's even A of T. T is which variable? What's the other one, huh? I mean, A is unknown and T is unknown. What are the two types of variables? Input, which is also known as there's another I word, something variable, used in science.
Initial.
Nope, because that's not.
I'm
How about-
thinking I words come.
How about it's something that can stand on its own, it doesn't need anything else? Independent variable, right? My input is my independent variable. A, the amount of accrued interest, that's why it's an A, accrued interest is dependent. Alright, let's pick up a calculator. Let's type a 1 in, and let's type a 5 in, and let's figure out what these are. So A of 1 is equal to, right? 1 is taking the place of T. You got your formula. Substitute that 1 in.
Raised to 1 times do we do T or like 5?
Well, remember that 1, because we need 1 year first. So what is being substituted in for T? 1.
I got false. I put it in and it said false, like it doesn't equal 1.
It's not supposed to equal 1.
It's just supposed to be 1, right, because it's times 1.
A of 1 would equal 500
I got that.
times 1 plus
Yeah.
0.06 divided by 1 raised to the 1 times 1. Gracie, you're just typing this in to
530.
evaluate the expression. 530?
Mhm.
You're just simplifying that expression. That's what you need to think about, Gracie. You're not solving an equation, you're simplifying an expression. Alright, so what is A of 5? There's no way I can do this in my head.
669.113.
113?
What my calculator told me.
Well, remember, that's decimals, that's not hundredths. Just say 669.113. Don't make it anything else but that, right? We have 1 in the tenths, 1 in the hundredths, 1 in the thousandths. But I'll even say this, does that number make sense if we're thinking about what Helen is doing?
For savings.
669 what?
Dollars.
Think about that number again, that number does not make sense. Actually, let me say this, that's very close to correct, but one of these numbers should not be there.
The one at the end, the 113, it's supposed to be like 2 digits.
Ah, it's money, right? We can't go past pennies.
For 670.
669.11. $669.11.
What?
LaShannon.
I don't even know when you get the 530.
I know, I got 30. It told me 30 when I put it in.
Then you didn't do 1 plus 0.06 divided by 1.
Oh, it's like a-
You gotta pay attention to that formula.
What do you get the 600?
We plugged in 5. The directions say 1 year and 5 years.
Oh, wait.
If you did 1 times.
Yeah, I see what I'm doing.
Yep.
Is the 530 money too?
Yes. Isn't she investing money?
Yeah.
And so what are we saying here? 1 what?
1
Year.
Remember, that's time. 1 year after investment, Helen's money is worth $530. 5 years after investment, 669. I'll go ahead and tell you this. You will never find a bank account that gives you a 6% interest. It's always way less than that.
Yeah, but
If you want anywhere close to 6%,
I like it all.
you'd have to invest.
But isn't it like the more money you
Stock
put
market.
in, the more you get out?
Yes,
Like,
but
if I
that,
put
but
1,000, I might get-
the interest you gain from a savings account in a bank will never keep up with inflation.
What's inflation?
It's the devaluing of money, essentially.
Do they just keep printing it or something?
Did you know when you work with the school system, they hold your first check? I was supposed to get paid today. This is dumb.
They don't hold your first check. It's something stupid about the way the laws are
So
written.
I didn't even get mine.
You won't get it. You won't get it until the month after. You have to have been working 2 months before you get your first month's paycheck. So
They don't do that in normal jobs though.
no.
They got my
It's called the
paycheck all
government.
fast.
Alright, suppose that the bank decides to start compounding interest at the end of every 6 months. If they still want to offer 6% per year, how much interest would they offer per 6-month period?
For her?
No, just in general. If they're deciding to compound at the end of every 6 months, and they wanted to still offer 6% per year, what percent would each 6 months get?
6%. Or 3%.
Right. It's just 6%. Split in half would be 3%.
And they might as well just
So you look at
6% a year because it's the same thing.
You actually get more money this way.
Oh, yeah, exactly. Twice.
You don't put,
And there you go. You get it compounded twice. Say again.
you don't put it in a little formula.
Well, so notice they're only asking how much interest would they offer, right? So 6% per year split in half would be 3% per year. So notice, like if we were to use this formula, and that's a really good point, now, actually I think that's what the next question is all about. So write a function to model the amount of money in Helen's savings account at the end of t years, compounded k times during the year, right? And so, actually, so no, don't, we're going to number 4, we're skipping number 3, but I do want you to see what Gracie is referring to here. If I change it so that I'm compounding it twice, it'd be 1 plus 0.06 divided by what? 2, raised to the 2 times t. Substitute the 1 in now. Right? Substitute 1 in now to see what you would have at the end of 1 year. Alright, so we're changing the formula slightly to compound twice. And so notice that 0.06 divided by 2, that's 3% per compound.
30, 45 cents.
534?
I got 561.
I got 5
Oh, I forgot a two.
Okay.
Yeah, 530.45.
530.45. So they give you a lot more. No, just
45 more cents.
45 more cents. But could that add up over time?
Yeah.
Yes.
Yeah.
Right? And that's what we want to recognize, that can add up over time. So write a function to model the amount of money in Helen's savings account at the end of t years, compounding k times. Well, what's her P, her initial investment? 500 times 1 plus, what's her interest rate?
6%.
So how would I write that? 0.06 divided by,
Well, if we're doing the first one, then do the 1. Which interest rate?
look at, well, the interest rate is still 6%. Look at number 4 again. It's just k, right? It doesn't say 2 times anymore. It's just, to be aware, it's divided by k. So then it'd be raised to what power?
TK, or KT.
kt. In the order doesn't matter, but yeah, we traditionally do kt. By the way, I don't know if you want to start doing this, but have I ever explained why I do t with a little swoop like that?
So,
Yeah.
so it's not a plus.
So you know it's not a plus sign. I would recommend that.
I don't
Okay.
get people giving their kids bank accounts once they're like 16. I'm like, if you had done that when they were 5, and every time their grandma gives them like $5 for their, you
Okay,
know,
we gotta
bank
focus on our
account,
math though.
that-
I
that's
know,
a-
but
that's a
we're-
real life thing.
This math, can be real life applied as well. You can apply it later, but we are behind and too far behind. Number 5, determine the amount of money in Helen's account. So we already have our equation of 500 times 1 plus 0.06 divided by k raised to the kt. So if we are doing this over 3 years and it's compounded twice a year, what is k?
3.
K?
Okay, it's 2.
K is 2, the number of times per year. And what's the time, the t?
3.
3.
Yeah.
The number of years is 3. If we look at monthly, what is k?
K would, monthly.
It's monthly, so it's what? 12. There's 12 months.
Oh.
What would t be? If it's daily, k is 365. T is 3. Plug those numbers in to your calculator and figure out what each of those will be. We'll talk about it in just a second. It shouldn't take us long. Remember, you can always scroll up to the previous thing and just hit enter to bring it down, so you only have to change a couple of details each time. You look like you have a question.
I'm just trying to get it to process.
So what's your question?
I feel like I missed something to make it make sense.
I mean, we're using this formula, like, if I had more time, I would go into explaining this formula, but we're just using this formula to figure out the accrued interest.
Is that it? The formula every time, or is it just?
That is the formula for accrued interest.
Okay.
Because notice, and it's very, you see how there's so many variables in here? So the P is my initial investment, always, they define that here. R is always the interest rate. And they tell you K is the number of compoundings, periods, right? So we're investing it, or they're compounding it monthly, so that K is 12. Daily, so it's 365. And then T is just your number of years. Does that explain it? Okay, so write those notes down. Let's make sure we're plugging these things into the calculator, figuring it out. What are you confused by? Did you write down the formula on number 4?
Yeah, well, yeah,
But number 4 is different than, oh, you wrote it here.
Yeah.
But you're just plugging in your K and plugging in your T.
To this equation, right?
Well, no, to this one, because there's a variable K and a variable T.
Okay.
I would write the actual equation we're using off here to the side, so that at least you know what formula we're using later, because we're about to go over this. Because once you start plugging in, and it shouldn't take long, you need to look at that formula again. Nope. 3 is the what? Nope. That's your T. Remember, T is your time. The denominator is K. Grayson, did you already get all 3 of them?
Mm-hmm.
Okay. No. So, do this one. Hit enter. And it brings it down so that you can edit those numbers. You have to bring it down though. Now, hold on again. Why'd you put a 3 down here? Why'd you put a 3 in that denominator? But is that denominator T? Look again, we never put T in the denominator, because denominator is K.
You have to, use this. You have to make it into an exponent. Those last 2 numbers.
Yeah, be careful y'all about your K versus your T. That is messing quite a few of you up. Okay. So, compounding it twice a year, what is the accrued interest?
597.8.
597.02. Everyone agree? Okay? And I should say, it's not accrued interest, it's accrued value. That's really what it is. So the monthly, 598.34. And then daily,
598.6.
so 0.60, 60 cents. So I want you to notice, does it increase when we compound more regularly? But does it slow down how quickly it's increasing?
Yes.
There's a limiting factor, is what's happening here. We're about to look at what that limiting factor is. But number 6, what effect does the frequency of compounding have on the amount of money in her savings account?
More frequent, more money.
Okay, more frequent compounding. Yields more money. As we said, it slows down the more we compound, like how much more it's getting, but the more frequent compounding yields more money. That's an important thing here. What we're about to look at is, what is the limiting factor? And so this is what we have, okay?
So,
Yes?
you know how there's interest, like, if you owe somebody money for a certain amount of time and it adds up?
Mm-hmm.
Is that the same rate that they use for, like, interest in your bank account? Like,
Not necessarily. They usually charge you way more interest than what you get in your bank account.
cause about to say, it's like our America, like, thing that we owe other countries goes up by like millions every like few seconds, but then accounts don't go that much.
But we need to stay on this map. So number 7, imagine that Helen finds a different bank that offers her 100% interest. Is that realistic?
Yeah.
Heck no. But it'd be nice, but it's going to help us discover an important mathematical principle. So notice how we have 100% interest, R is equal to 1 for every single one of these formula, and we have a different K every single time. So, if K is 12, it's monthly, and so my formula, remember she's only starting with $1, so 1 times 1 plus 1 divided by 12. Oh, we still actually need to do this one. First of all, really quickly, do we all get this formula? Are y'all okay if I just put this into the calculator and we see what the numbers come out to be? Okay. For the monthly one, we haven't gotten there yet, but, so let's look at this. Does anyone remember a part of the calculator that works just like Excel?
You said?
Listen spreadsheets, okay? So what I'm going to look at is my value for K. And if it's yearly, what is the K value? 1, right? If it's, what's the next one? 2, was semi-annually, and then it was quarterly, 4, monthly.
12.
What's the next one, daily? Oh, weekly, how many weeks? No, how many weeks are there? 52, fam. There are 52 weeks in a
They
year.
never told us that. Like, I've
52
never
weeks
had
in a
that
year.
number in my life.
What's the next one, daily? 365. Minute. Oh, is it hourly? So I'll say this, does anyone know that off the top of their head? No, that'd be crazy. But there's 365 days, and how many hours are in each day?
Wait, I can.
24. So I'm going to type in equals 365 times 24. There we go. That's how many hours are in a year. It's way less than I thought it would be. So then, is it minutely after that?
Yes.
How many minutes are in an hour? So I'm going to take my 8760 and multiply that by 60.
Oh, I should get.
Okay.
That's a song.
525,600 minutes. That is a song.
It is.
From?
I know I've heard
Anybody know?
Oh,
Bye-bye. No?
Oh, it's a commercial.
I thought that's what it was called.
No, it's a song from Rent, the musical.
Oh.
That's what I heard.
All right.
It's not when they sing something.
So,
We don't sing the whole
and then how many seconds are in a minute?
31
It's a lot.
2 minutes.
How many?
31,500,000.
That's not the question I asked. I asked how many seconds are in a minute. 60.
Oh, 60, I think you're asking.
I know. Okay, so there's that. Now, the whole point of me putting all of that in is, remember, I can type an equation in. So, what is my p-value? My initial investment?
One, oh, for which one?
For this problem, number 7, 1. 1 plus, what's her interest rate? What's her interest rate? What's her interest rate?
Oh,
100%. It says it in the directions. Number 7. What's it say about her percentage? 100%, right? So what would that be as a decimal? 1 divided by, now remember the whole point is, it's divided by k, which that's my variable here. That's why I defined all my k's. Raised to
1 times K.
k times 1, right? Remember k times the number of years. Alright, so I'm going to make sure it knows that this is a variable reference. Oh, that's great. Let's do this. This will make it work. So I don't want fractions, was why I said it was great. There we go. So notice if we get 100% interest and we compound once, we get $2. Twice, $2.25, $2.44, $2.61, $2.69, $2.71, $2.718, $2.718, $2.718. Notice, look at the, I don't know if you can fully see this, but I want you to see these decimals, hopefully. So notice how, remember how we said that there's a limiting factor? Yes? No? Maybe so?
Yeah, they're all the same now.
Why is mine a fraction?
The calculator is automatically set to do fractions. If you remember, I went up and I put a decimal after one of the ones to give it a decimal, or to give a, to get a decimal. And so I want you to notice right here at 525,600, 2.7182792 is what we see right there. But if I go down one more, 2.71828, right? So that's just a little bit more. But we see how it's still growing, it's still increasing. So if I were to compound even more frequently, it would still increase, but would it increase by a lot? No. This is an important number. First off, do I need to scroll up so we can get some more of these decimals?
Yeah.
Okay. Write some more of the decimals out. I would probably say 4 decimals for each of these. Because I know it's money, but there's a reason why I say 4 decimals. Is that high enough? Right, because 4 was the first number on there.
Can you write one of these out? Like,
What do you mean?
one of the formulas, for like, 52?
So remember, it's always 1 plus, or times 1 plus,
1 over 52.
because remember that 1 is my R, that's my interest rate, divided by K, which K is 52, because it's weekly, raised to the 52, that's K again, times T, which is the number of years, and it's only 1 year. Right? So we're just plugging in that 52 for K. Let me know when I can scroll down, please. Can I scroll down to the last couple? Just focus on the numbers right now, don't worry about the formulas, I need you to write down the numbers. That is more important. So I want you to notice number 8 says, make an observation about the frequency of compounding and the amount that Helen earns. What amount is it approaching? So the maximum value approaches what number? 2.72.
Well, because they're all 2.71, they never get there, so they,
2.8. 2.1.
What, seven, what,
2.7, 1, 8,
3.
2,
Why not?
8. The reason, so again, I know this is financially based, but this number matters, okay? But do we see how it's like starting to flatten out and really, I think the number before that was 2.71827. We may not have written that down, but it was approaching that 2.71827, then we get 2.71828. And so here's the next page, and this is where it gets important. I'm going to add one detail in here that the book does not have, because it's useful. Oh, never mind, they do have it in here. They just don't have it bolded. So this number here, right? The amount of Helen's earnings approach is actually an irrational number called E. Does that number E, being 2.71828, 1828, 459, that irrational number is named E. Do you know of any other irrational numbers that have a name to them? I is imaginary. Remember, it's not irrational. It's a good thought, but that'd be the square root of -1. It's not irrational, it's just imaginary. Huh?
It's pi.
Pi. I don't know if the number is E. Z stands for Zahlen or something like that. It's a German word that stands for integer. But the number pi, haven't y'all dealt with pi before? Right? 3.1415926, that's as far as I know, but it continues after that. They have 265 here. But I will point this out, we're used to pi being a number, but you know pi is a letter, right?
The pi letter.
No? In Greek, yeah, pi is a Greek letter. The fraternity systems that all have alpha phi, alpha gamma, whatever. I don't know any of them because I didn't do Greek life, but all of those are Greek letters for different fraternity and sorority houses. But pi is a Greek letter, just like we have E is an important number. So E, you got to know it. It is known as the natural base. That is in the Big Ideas graphic organizer. Make a note to yourself on this page. Don't get the graphic organizer out right now because we got to go. But E